Okay. Good morning, my lovely viewers. You are welcome to this morning class. This morning we are going to continue where we stopped yesterday. We had to solve so many examples, excuse me, last night, but so unfortunate that the rain came. The weather was not friendly to the network, so I have to suspend the class till this morning. So you are welcome. How was your night? Hope it was fine. Please, I want you to do me a favor, like, comment, and share. Also, subscribe. I'll be very grateful. Is that clear? So this morning will be. Oh, sorry for the break in transmission. Very sorry, that will be network issue. Is that clear? Very sorry. Very sorry for the break in transmission. Okay, so as I was saying, I said when you come across questions like this, what you first do is to define the Picard method mathematically. And this is the formula for Picard. Y subscript n plus 1 equals to y subscript n plus integral x naught to x f of x comma y subscript n dx. So this is the formula for Picard. So I'm going to break this solution or this how to solve this problem step by step. I will always assume that this is your first time of seeing this type of question. Is that clear? So I will break it the way you understand it. But if there is any question, don't hesitate to ask. Thank you and God bless you. Yeah. So can we continue? We can continue, right? Okay. Yeah. So let us proceed to solve this this Picard. I want us to take note of things. There are things you should take note. Let's go back to the question. The question said apply Picard's method to approximate the value of y when x equals to 0.1. It means before this x equals to 0.1 will come in, you might have done with your what? Come here. They said up to 2 approximation. It means the iteration, you are going to iterate it up to how many times? Twice. So you are done with the iteration. That is when you apply or introduce this x equals to 0. In order to find the value of what? Y. Y here. Take note. Then another thing you should consider is, given that, these are boundary conditions. So always bear it in mind that if we have only one boundary condition on y equals to this and x equals to this, it is always assumed that our y naught is equals to 1. That's the meaning. Is that clear? That is, this implies y. Then it is always assumed that our x naught is equals to, given as what? 0, which implies what? Implies x. So take note. So when I begin to substitute, don't get confused. Take note of all this. And any question, please? Any question? Okay. So as you can see now, look here. So when, this is a first order derivative. It means this f of x, comma, y n is equal to this function, is 3x plus y squared. So you should take note of all this. Is that clear? Take note. So can we continue? Can we continue? Okay, can we continue, right? Okay, let's go ahead and continue. So as I was saying, so this implies that our function, amen, our function will now be y subscript m plus 1 equals to y subscript m plus integral x naught to x. Then it means our f of x is this function, right? So 3x plus y squared, but mind you, n here is what? Y here is n subscript n, all in brackets, d what? dx. Amen? Do you understand, right? Are you following? Okay. So now we putting n. We want to start the iteration now, because they said we should iterate up to 2 approximation. So any iteration that will start, it must start from what? 0. True or false? The initial point. True or false? So it means we now write putting n equals to what? 0. Can you see now? So if n is equals to 0, it means we are going to have y subscript 0, 1, 0 plus 1 equals to y subscript 0 plus, then note that, and x naught is equals to 0. True or false? Okay, let's let go of that first. Let's forget about this first. So integral x naught to x, then 3x plus y squared 0, all in brackets dx. Amen? Yeah. Can you see the beauty of this function now? Are you seeing the beauty? Any question at this point, please ask. Do you have any question? Any question? Yes or no? No question. So it means we can proceed. Please, I want you to like and comment. Also share. Okay. If there is no question, it means we can proceed, right? So we now introduce x naught equals to what? 0, and y naught equals to what? 1. Is that clear? Okay. Then 0 plus 1 is 1. So here will be y1 subscript 1 equals to y naught is what? 1 plus integral, okay, y naught is 1 and x naught is 0 plus integral 0 to x, open bracket, 3x plus y naught is 1, but y is squared. True or false? All in square dx. Because I will break it down in a way that Even if you are not a mathematician, you should know what I'm trying to do. Is that clear? I'm not going to rush you. Okay, so if you agree with me here, so we can have it in this form. Yeah, let's come here. This is the same thing as 1 because 1 raised to power 1 is 1. True or false? So here, our y1 will now be equals to 1 plus integral 0 to x, 3x plus 1 dx. Do you agree with me? You agree with me up to this point, right? So it means what we need to do, we have to, these are definite integrals. Why? Because we integrate to obtain a value because of the lower and the upper limit. So we refer them as what? Definite integral. So as a mathematician, you suppose know what definite integrals, how to integrate them. I know some of you, to integrate this function, we want to obtain a constant, which is not true. Yeah, so is that clear? So this is what we are going to do. If we integrate this, our y1 is equals to 1 plus integrate this function, we are going to, if you integrate 3x, we are going to have 3x squared all over what? 2. Then plus if you integrate 1, we are going to have what? X. Then open bracket at 0 to x, right? So this implies that subtract the lower limit from the upper limit, which you know that even if you subtract this other side will be 0, true or false. But here, even if you write, you replace it with x is the same x and the same distance. So this implies that our y1 is equals to what? 1 plus 3x squared all over 2 plus x. Then let us write it orderly, or we can transform it in this form, equals to 1 plus x plus 3x squared all over what? 2. This is our y1. Any question, please ask. Ask your question. If there's any question, please ask. I want you to ask. Akwenja, good morning. How are you? And where are you watching from? Kanishaka, where are you watching from? Which country? Okay. So let's proceed further. That is our yeah. So no question. So we can proceed, right? So this is our y1. So now I said every iteration starts from the origin, which is 0. So after 0, 1, 2. Is that clear? So now we want to put n equals to 2 by using this. If we put n equals to 2, we now write, let's write. So putting n equals to what? Sorry, 1, not 2, because after 0 is 1. So it means, let's come here, look at it. Let's look at it. So it means here will be 1, true or false? So 1 subscript 1 plus 1 equals to, here will be 1, 1 y subscript 1. Then what we have here? Plus, true or false? It's true. So plus integral x naught to x. Then the function is 3x plus y subscript n squared. Open close bracket, yes, right? So here will be 3x plus y squared. Since putting n equals to 1, so here will be 1, amen. Close bracket, the x. Yeah. Look at how beautiful it is. Amen. Yeah. You know, life of mathematics is always beautiful with Mr. OSI. So, can you see now? So, it means we have to recall. We have to have this. So, it means this is the first iteration. So, we have to recall this. Y1 plus 1 is 2 equals to, where you know that your y1 is given as this, true of us. It's true. So y1 is given as 1 plus x plus 3x squared all over 2, then integral x naught to x. So here we are going to write, just look at what I want to do here. You have to be very careful. Here we have 3x plus y1 squared, true or false? So we write 3x, then plus, amen? Yeah, plus what? We know that y1 is this, true or false? Y1 is this. So here we are going to have another bracket for it. 1 plus x plus 3x squared all over 2, all in square. Then open brackets, the x. Am I communicating? Look at the board very well. Look at the board very well. Am I communicating? True or false? Am I right? I'm right, right? Okay. So if you agree with me, let's proceed further to solve it. As you can see, you don't need a prophet to tell you. You don't need a prophet to tell you. Yeah. Don't need a prophet. Okay. So what we need to do here is also, can I clean this up? Yeah. Let us remember that our y. Okay, we have already substituted. Remember that our x naught is equals to 0, right? Here will be y2 equals to 1 plus x plus 3x squared all over 2, then plus integral, okay? Integral, it means 0 to what? X, right? But I want us to do something here. Let's do something here. Let us expand this. Because we have this in this form, 1 plus x plus 3x squared all over 2. All is squared, true or false? So it means this is the same thing as 1 plus x plus 3x squared all over 2 times 1 plus x plus 3x squared all over 2. This is equals to, let's multiply. Let's put it there. This will be equals 1 times 1, 1 plus x plus 3x squared all over 2. This times this plus x, this times this plus x squared, this times this plus 3x raised to the power of 3 all over 2. This times this plus 3x squared all over 2. This times this plus 3x raised to the power 3 all over 2. Then this times this, we are going to have 9x raised to the power of what? 4 all over 4. True or false? This is what we are supposed to get from this bracket. So it means we can add. True or false? We can add. We can add. If we can add, any question, please? Any question? No question. So if we can add, since we can add this to this, and which other one? We can add this to this, and also add this to this. True or false? Okay? So here will be 1 plus this 2x, this plus this is supposed to be plus x squared, then plus 6x squared all over 2. But if you can see what I am saying, it means if you add this, you are going to have 3x squared. 3x squared, then add this to this, you are still going to have plus 3x cubed, then this is 9x raised to the power 4 all over 4. True or false? It's true, right? Hope I'm communicating. Am I communicating? Look at the board very well. Look at what I'm trying to do. This is 1. Add this to this, 2x. Then add this to this. You are going to have 6x squared all over 2. It's the same thing as 3x squared. Then add this 3x cubed all over 2 to 3x cubed all over 2. You are going to have 3x cubed plus 9x raised to the power 4 all over what? So we can have this, true or false, to give us 1 plus 2x plus 4x squared plus 3x cubed plus 9x raised to the power of 4 all over 4, right? Yeah, this is what we are supposed to have. And here we have 3. So I can clean this up. That is mathematics for you. I can clean this up to give us a So the integral, mind you, we have 3x. We're able to expand this bracket to give us this. So let's write. Open brackets. 3x plus 1 plus 2x plus 4x squared plus 3x cubed plus 9x raised to the power 4 all over what? 4. Close bracket dx. Did I commit any offense? Please look at the board very well. Look at it. Any question, please? Ask your question. If you have any question, ask. No question. Okay. So if there's no question, let's proceed. I can clean this. There's no question. Let us proceed. Okay. Yeah, it's simple as ABC. If you can see what I'm saying, you can add this together. So it means our y2 is equals to 1 plus x plus 3x squared all over 2 plus integral, let me write it well, plus integral 0 to x. Here will be 1 plus 3x plus 2 and 5x plus 4x squared plus 3x cubed plus 9x raised to the power of 4 all over 4 close bracket dx. So what we need to do, we have to what? Integrate this function. So thank God that all of us will know how to integrate. So when we integrate, our y substitute 2 is equal to 1 plus x plus 3x squared all over 2. Then here will be plus. If you integrate, you have x plus integrate this, you are going to have 5x squared all over 2. Plus integrate this, you have 4x cubed all over 3. Integrate this, you have 3x raised to the power 4 all over 4. Then lastly, integrate this, you are going to have plus 9x raised to the power 5 all over 5 times 4 is 20. Then since this is a definite integral at 0 to what? X. But if you subtract the lower limit from the upper limit, it's still going to give you just the upper limit, true or false. Already we have x here, so there is no need, so we just leave it like that. Here will now be y2 is equals to 1 plus x plus 3x squared all over 2 plus x plus 5x squared all over 2 plus 4x raised to the power of 3 all over 3 plus 3x raised to the power 4 all over 4 plus 9x raised to the power of 5 all over what? 20. After substituting in the limits. Any question here, please ask. Do you have any question? Do you have any question? Please, if you have any question, ask. Ask your question. No question? But I want us to understand one thing here. Yeah, we know that our first iteration we got 1 plus x plus 3x squared all over 2. But here our y1, you know, in the boundary condition, our y1 is given as what? 1. So this implies that here it's supposed to be what? 1. I want us to take note. Is that clear? So if you agree with me, it means here this place is going to be 1, because go back to the boundary condition, the iteration started y equals to what? 1, true or false. So if n is equals to 1, y subscript n equals to 1, then if our n is 0, our y naught will be 0. But now our y1, our n is 1. So it means our n will now be what? 1. So yeah, I was doing it intentionally just to explain this to you, so that you'll not get it wrong. So if you can see what I have seen, even here too, here, the whole of this, come back here, look at it. This is it. That is here. Go back to the question, the boundary condition. Y is equals to 1, true or false? So since we assume n equals to 1, so our y1 in the boundary condition, by applying x naught is always 0. So here will now be what? 1. Do you understand? So here, this place 2 will be 1, and here 2 will be what? Will be 1. True or false? So let's take note. So if you agree with me, we are going to consider these parts. Yeah. We'll just consider here. True or false? We'll consider here. Let me clean here. Go back to the boundary condition, please. So far, so good. So our y is equals to boundary condition. Here, instead of this, we write what? 1. Is that clear? Plus x plus 5x squared all over 2 plus 4x raised to the power 3 all over 3, then plus 3x raised to the power 4 all over 4 plus 9x raised to the power 5 all over what? 20. Look at the board very well. Are you seeing it? Are you seeing it? Any question? Or did you discover any mistake? So look at the board. Look at the board very well. Okay, so we can continue, right? Then they said, according to the question, they said we should find y when x is equals to 0.1. Two of us. So this is the y we are going to find. Is that clear? This is the y. So by the time we put y, so it means our second iteration, this is our first iteration, then this is our second iteration. Is that clear? So it means our second iteration will now be, this. So for us to obtain the value of y, we have to make use of this. So it implies that y of x is this, equals to 1 plus x plus 5x squared all over 2 plus 4x raised to power 3 all over 3 plus 3x raised to power 4 all over 4 plus 9x raised to the power of 5 all over what? 20. So since our x is 0.1, so our y of 0.1 now, because anywhere you see x, you write 0.1, 1 plus 0.1 plus 5 open bracket 0.1 all in square all over what? 2 plus 4 open bracket 0.1 all in raised to power 3 all over 3. Then I'm going to clean this part, but yeah, okay. Then plus here we have 3 open brackets 0.1 raised to the power of 4 all over 4 plus 9 open brackets 0.1 raised to the power of 5 all over what? 20. So this is how to obtain the value of y. So what you need to do, you just press your calculator and obtain your value, and that is the end. Any question, please. I'm giving you 1 minute to entertain your questions. Thank you. No question? So it means we can proceed further, right? There is no question, we can proceed further. Yeah, we are still on Picard. Let's solve more examples. That will help you in your exams. Amen. Let us go ahead and solve more examples. Okay, one of the examples says using Picard's methods. So example, using Picard's method to solve dy dy all over dx equals to x plus y. Then the boundary conditions, or y squared, sorry, the boundary conditions is given as x naught equals to 0. Equals to 0. We are going to solve this together. We'll solve it together. Is that clear? We are going to solve it together. We'll solve it together. Okay. So let's proceed to solve this Picard. But before we can solve this, I told us that we should always define Picard mathematically, two of us. So the mathematical definition of Picard is y subscript n plus 1 is equals to y subscript n plus integral x naught to x. Then our f of x comma y subscript n dx, two of us. Then I told us that this is the boundary condition, initial value. This is this is initial value. Please just sorry about that. I'll be mentioning boundary condition is initial value. Please, sorry. So the initial value has been given as y of x equals to what? 0. So you can now see with me that this is how it's supposed to be. Y of x, y of 0 equals to 0. It's supposed to be y of what? X equals to what? 0. This is how the initial value is supposed to be. So it means, since we are talking about x, y, n, so if now we transform it in this form, if n is 0, it means our initial value here is always x naught, which is what? Equals to 0. So this implies that our y naught is equals to 0 and x naught is equals to 0. Please take note. You should take note. Is that clear? So what we need to do then, here our function, our f of x comma y n is always equals to this, the right hand side of the derivative, which is what? X plus y squared. Then since our y is what? N. So this is how it's supposed to be. So if you know how to identify all this, I don't think Picard's iteration will be a problem. Is that clear? Any question? Want to go ahead to solve this problem? So let's move further to solve this. Let us move further to solve this. Amen? Yeah. Okay. Here, let's solve this. Let's solve this. So our y will now be y subscript n plus 1 is equals to y subscript n plus integral x naught to x. Note that our f of x is this. So x plus y squared subscript n close bracket the what? The x, right? Okay. So since we are talking about iteration, right? So let us iterate it from the origin, that is initial point. So it means when our n, we now write putting n equals to 0. If we put n equals to 0, it means the left hand side will now be 0 plus 1, y subscript 0 plus 1, then y subscript what? 0 plus integral x naught to x then our x plus y not all is square dx. True or false? Any question? Do you have any question that you want to ask? Any question? Please ask. Do you have any question that you want to ask? Any question? No question? Okay. Then, here, the initial value is given as, it means y naught is equal to 0 and x naught is 0, right? So we substitute x0 already. Here will be 0 and y1, the 0 plus 1 is equal to, here will be 0 plus integral x naught is 0, x, then x plus, this is 0 squared. True or false? Dx. True or false? Yeah. So the whole thing will now be y is equals to integral 0 to x dx. So let's integrate this. If we integrate this, our y1 now be equals to x raised to the power of 2 all over 2 at 0 to what? X. Finally, our y1 will now be x raised to, if you subtract the lower limit from the upper limits, this is what it will still be. Any question at this point? Ask your question, please. If you have any question, ask. Do you have any question? No question? Okay. So let's continue again. Let us continue. So if we now put, there is no question, let us, I know they do not ask us to up to so approximation, but we are going to continue. We'll continue. Is that clear? So let's continue. Let us continue. So if you can see what I am saying here, we're now putting n equals to what? 1. So let's come here. Here will now be y1 plus 1 equals to y1 plus integral x naught to x, then x plus y1 is this x squared all over 2, but y is squared all in bracket the x. But here, our y1 is what? The y1 here is 0, true or false? So we continue. So it means here will be y2 is equals to here is 0 plus our x naught is 0, right? Integral 0 to what? X, then open bracket x plus here we apply what? Indices. True or false? Huh? But not only this, we should also consider the denominator. So here will be x raised to power 4 all over 4 dx. True or false? When you have x squared all over 2 all in bracket square, this is the same thing as x squared all over 2 times x squared all over 2. So 2 times 2, 4. Then you apply indices. So x raised to the power of 4. Any question, please? Ask your question. Ask your question. Let me give you 1 minute. Ask your question. No question? Okay, let me clean this. There is no question. So that we can continue with our solving. Okay? Okay. Yeah. So let's look at it. Let's look at this. So here is 0. Ready? Here will be y2 is equals to integral 0 to x, then x plus x raised to the power of 4 all over 4 times dx, right? So if you can see what I am saying, let us integrate and substitute in the limit. So y now be equals to x raised to the power of 2 all over 2 plus x raised to the power of what? 5 all over 20. Two of us at 0 to what? X, isn't it? So if you can see what I am saying, this is the same thing as y2 is equals to, when we substitute in the limit, it's the same thing as this, x raised to the power of 2 all over 2 plus x raised to the power 5 all over what? 20. Any question? Do you have any question? Any question? No question? So we can proceed further, right? So let us continue to put n equals to what? 2. So when we put n equals to 2, it means putting n equals to 2. Amen. So if we put n equals to 2, this will now be, let's come here. Let us come back here. So here will now y subscript what? 2 plus 1 equals to, here will be what? Y subscript 2 plus integral x naught to x, then here will be open bracket x plus y subscript what? 2 square, close bracket dx. Okay. Yeah. Let's come here. Can you see now? Here will always refer you to not here. This is the iteration. Is that clear? This is the iteration, y2 iteration. So this and this, they are not the same. Just take note. This represents the initial value condition here. But our y2 in the initial value condition is always 0 here, because it means our n is 2. So here will be y2, which is equals to 0. And already our x naught is also 0. So the left answer will now be 2 plus 1 is what? 3. So 3 equals to 0 plus integral x naught is 0 to x. Then here we are going to have x plus y2 is this. We substitute in the iteration of y2. So y2 is x raised to power 2 all over 2 plus x raised to power 5 all over 20, all in bracket, raised to power 2, close bracket, what? dx. True or false? Because our iteration y2 is this. So instead of y2, we write the iteration of y2, look at it. But y2 has what? Square, raised to power 2. So you have to all in bracket raised to power 2. Do you understand up to this point? Any question, please ask. If you have any question, ask. If you have any question, ask. Any question? No question? It means we can proceed if there is no question. Okay? Okay. If there is no question, let us proceed. Let's proceed. Let's proceed. So, where do you want me to clean? Always remember that y naught is equals to 0. It means either y1 is equals to 0, x naught equals to 0, or y2 equals to 0, and x naught equals to 0, then y3 equals to 0, and x naught equals to 0. This is the initial condition value. So it means we have to what? Expand this and integrate this. So how can we do that? We need to clean this up, two of us. So let us clean this up. Let's clean this up. Let us clean this up. Okay. Let's clean this up. Amen. Okay. Yeah. So we can continue. Before we can be able to integrate this function, let us expand this. Let's expand this. Let us expand this. You know very well, two of us, that if we have x squared all over 2 plus x raised to power 5 all over 20 all in square, this is the same thing as x squared all over 2 plus plus x raised to power 5 all over 20 times x squared all over 2 plus x raised to power 5 all over 20. True or false? True or false? People have been calling. Sorry about that. Okay, let's proceed. Let us proceed further. Let us proceed. Amen. Okay. Yeah. So as you can see now, this here will give us this, but we can have this to give us here will be 4 raised to x raised to power 4 all over what? 40 is 20 10 all over what? 400. True or false? It's true, right? Okay, so let's proceed to consider this. Already here is 0. So our y3 is equals to 0 plus, is not necessary, just write integral 0 to x, then open brackets x plus, already expanded it to be in this form. So here will be plus x raised to the power of 4 all over 2, plus x raised to the power 7 all over 20, then plus x raised to the power 10 all over what? 400, all in brackets, yes. Do you agree with me up to this point? Look up, look at the board very well. You agree with me, right? Look at the board very well. Do you agree with me? Okay, so if you agree with me, let us proceed. Okay, please, I want you to like, comment, and share. So if you agree with me, okay, let's proceed. So we have to integrate this function. So when we integrate this function, this is what we are supposed to get. 2 all over 2, then plus here is x all over 20, then plus here is 8 times 20 is 160, right? So x raised to the power of 8 all over 160, then here is x raised to 1 times 400 is 4,400, right? Then at 0 to x. So when you substitute this, it means our y3 is equals to y equals to 3 is equals to x raised to the power of 2 all over 2 plus, because this always turn to 0, but we have x here. So even if you remove this x and put x, put x, put x, put x here, it's the same thing. It will appear exactly like. Is that clear? Here will be x raised to the power of 5 all over 20 plus 8x raised to the power of 8 all over 60 plus 8x raised to the power of 11 all over 4400. 4,400. Any question at this point? So far, so good. So what we need to write, we don't need to this is third. So this means that means that our y of x is 2 all over 2 plus x raised to the power of 5 all over 20 plus x raised to the power of what? 8 all over 160 plus x raised to the power of 11 all over 4400. Do you agree with me? This is how you are going to evaluate this. We'll still move further to consider more examples. Is that clear? Any question? Look at the board and ask your question. I'll be very grateful to consider your questions. Yeah, we have here. These ones I'm solving from exercises. Solving from exercise. So just be grateful for what I'm doing. Okay, I can clean this, right? Let me clean this. Any question? No question. Let's move further to solve and solve. can also clean here. Love what I am doing for you. I want you to like, comment, and share. I'll be very grateful. May God bless you for doing so. If you like what I am doing for you, comment, like, love, subscribe, and share. It's okay. Let's consider more examples. Here we have using Picard's iteration method. Okay. Using Picard's iteration method to solve dy all over dx, dy all over dx equals to x minus y. The initial condition, initial value is given as y of 0 equals to 1, and they said and find y of 0.2. Okay, this is simple as ABC. Is that clear? If you have been following what we are doing here, I don't think this will be a problem to you. Is that clear? We'll do it together. Anyway, I'll do it together. Okay, so it means at first we should define what Picard is all about mathematically. So let us define Picard mathematically. It means Picard is our Picard's iteration method is given as y subscript n plus 1 equals to y subscript n plus integral x naught to x, then f of x comma y n. The what? The x. This is the mathematical definition of Picard. Is that clear? But I want us to know one or two things before we take the journey mathematically. Is that clear? Okay. So here, let us try to identify the initial value condition. What does all these things mean? At first, when you see y of x equals to 1, but by right, this is how it's supposed to be. Why? Because it has to do with x. The function here, the independent variable here is x. So this is how it's supposed to be, equals to what? 1, the initial value condition, right? So this means that y is equals to 1, and this x, what equals to 0. But this x is always x naught, which is this. But the y is attached with what? N. So if we assume n equals to 0, y naught will be what? 1. Take note, very important. Then by the time we assume n equals to 1, it means y1 is still equals to what? 1 in the initial value condition. Initial value. Do you understand? Please, you have to be very careful. Is that clear? So we should take note of this. Then after solving your x, they said your y is 0. What? So it means here is the x, two of us. So anything you obtain, you now substitute into what you have got. That is what you want to do now. So any question? Any question? Do you have any question, please? Sorry about the network. Do you have any question, please? That is what I'm trying to say is this. I say I want us to understand some certain things before we take the journey. Like here, we see y of 0 equals to 1. But by right, this is how it's supposed to be. Y of x equals to 1. This is the initial value condition. So when you come across things like this, that is what I want to explain to you. Listen attentively. Is that clear? When you come across values like this, in the Picard, our y is always subscript n. So if our x is x naught, true or false. So this implies that if n equals to 0, our y naught is equals to 1. Our y naught, this y is always equals to 1. Then the y naught, the 0 here, is our x naught. Take note. Is that clear? So I was trying to explain something like that, but the network was bad. Sorry about that. Okay. So can we proceed now? Let's proceed. So let us proceed. Then here our f of x comma y subscript n is always equals to the right answer, which is x minus what? Y. So let us move further to consider this. Amen. So if you can see what I have seen, if we now say putting n equals to 0, this is y subscript 0 plus 1 equals to y naught plus integral x naught to x. Then our function is what? Open bracket x minus y dx. Amen? Yeah. So let us come back to the initial value condition. The initial value condition, please, point of correction, both the other videos have been calling boundary conditions. Please, this is not boundary condition, this is initial value. Is that clear? Please, take note. So, should in case you watch the other videos and I've been mentioning boundary condition, please just correct it. Is that clear? Is an initial value. Take note. Thank you. So, this initial value, as I have said, so it means this initial value, y naught is what? 1, because it's equals to 1, and x naught is what? 0. Take note. Is that clear? Do you understand? Hope you are following. So if you can see what I am saying, look up here. If you can see what I am saying, here we are going to consider 0 plus 1 is 1. So here will be y1 equals to y naught is 1 plus x naught is what? X naught is 0. 0 to what? X. Then open bracket x minus y dx. So at this point, what we need to do, we have to integrate this function. Do you agree with me? If we are to integrate this function, it means our y1 will now be equals to 1 plus, integrate this function, we are going to have x raised to the powers of what? 2 all over 2, then minus x, y, close bracket, at 0 to what? X, at 0 to x. Do you agree with me? Yeah. So if we substitute in the value, if when we substitute in the value, oh, sorry, I want to make a mistake. Yeah, sorry about it. Very sorry about this. Sorry about this. Here is supposed to be n, but when n equals to 0, this is 0. True or false? So here will be what? Y naught is 1. True or false? So here will be 1. Please, here will be 1. That is why it's good. Yeah, I earlier discovered my mistake. Here will be 1. True or false? It's true, right? It is true. It is true. Okay. So let's proceed to integrate this function. When we integrate this function, we are going to have x all over 2, x squared all over 2, then minus x at 0 to what? X. True or false? So this implies that our y will now be 1 plus 1 plus what? X squared all over 2, because we subtract the lower limits, minus x. True or false? So this is the same thing as we can write this y1 is equals to 1 minus x plus x squared all over 2. True or false? It's true, right? Look at the board very well. True or false? It is true. So let us proceed further. Let's proceed further to assume putting when n equals to 1, we come here again to write y subscript 1 plus 1 equals to y1 plus integral x naught is already 0 to x. Then this is what? Okay. This is here is our x1. True or false? Isn't it? Here would be what? A function. Okay, here it's supposed to be. Okay, anyhow, x minus y1, this is this, open bracket, 1 minus x plus x squared all over 2, close bracket, close the other bracket. True or false? Am I communicating? Am I communicating? Yeah. So if you can see what I am saying, already our y is equals to what? 1, right? So y2, 1 plus 1 equals to 1 plus integral 0 to x, true or false? Then open bracket x, multiply this out, minus 1 plus x minus x squared all over 2, close brackets. Yeah. So what are we going to do? We have to integrate this function. Let's integrate this function. So when we integrate this function, y is equals to our second iteration will now be 1 plus here will be x raised to power 2 all over 2. Here will be minus x. Here will be x raised to the powers of 2, but okay, let's do it this way first, so that we'll not be repeating. Is that clear? Because I discovered that we can add this and this, so let us do that first. So our y2 is equals to 1 plus integral 0 to x, open bracket, x plus x is 2x minus 1 minus x squared all over 2 dx. Do you agree with me? Amen? Do you agree with me? You agree with me, right? Okay. So if you agree with me, it means let us integrate this function. When we integrate this function, we are going to have y2 is equals to 1 plus, integrate this, we are going to have 2x raised to the power of 2 all over 2 minus x raised to the powers of 3 all over what? 6 at 0 to what? X. 2 of us. It's 2, right? So if you can see what I am saying, this and this will cancel to give us y is equals to, when we substitute in the limits, it's the same thing we are going to have. There will be 1 plus x squared minus x raised to the powers of 3 all over 6. Is that clear? So we can write it in this form. y2 is equals to 1 minus x plus x squared minus x raised to the powers of 3 all over what? 6. Any question up to this point? Do you have any question? Yes or no? Yes or no? Any question? Yes or no? No question? No question. Okay, let's proceed to put n equals to, because we are on iteration, n equals to what? 1, right? So by the time we write putting n equals to 2 this time, so let us come here, right? Okay? Okay, already I've substituted in the value. Okay, let's come here. So if we come here will be what? 2. Here will be y2 plus 1 equals to y2 plus integral. Already our x naught is what? 0 to x, then open bracket x minus our yn is 2. So we substitute in this, we put small bracket for this 1 minus x plus x squared minus x raised to power 3 all over 6, close bracket, open, close the bracket again, then the x. So we have to multiply out this. Okay, so 2 plus 1 is going to be what? 3. y3 is equals to y2. But let's come to the initial value condition. The initial value condition, our y2 is what? 1. So here will be what? 1. So let's just say y2 is 1 and x naught. Already we have done that, so there's no need. So here will be 1 plus integral 0 to x, then open bracket x minus times 1 is minus 1, minus times minus x. We are going to have plus x, minus times plus x squared minus x squared, minus times minus x cubed all over 6 plus x cubed all over 6 close bracket dx. Do you agree with me up to this point? Look at it. Amen. Are you seeing what I am saying? Any question? Please ask. Any question? Do you have any question? No question? It means we can proceed. So can I clean this up? I want to clean this up for us to proceed. Okay. For us to proceed further so that we can grow mathematically. Amen. Okay. Yeah. So at this point, what we need to do here is what? Is to integrate this function. So let us integrate this function. So here, y3 is equals to 1 plus integral 0 to, okay, we are integrating. So when we integrate this, we are going to have x raised to power 2 all over 2 minus integrate minus 1. You have x, then integrate x. Oh, okay. Okay, before we do that, I think we can have this and this, two of us, so that we will not be repeating. So let us orderly arrange it first. This is y3 is equals to 1 plus integral 0 to x, open bracket, x plus x, 2x minus 1, minus x squared plus x raised to the power of 3 all over 6, close bracket, dx. Two of us. It's true, right? So let's integrate this function now. When we integrate, y subscript 3 is equals to 1 plus 2x squared all over 2 minus x, then minus x raised to the power of 3 all over 3, amen, then plus x raised to the power 4 all over 18 at 0 to what? X. Am I right? Am I right? Look at it. Look at the board very well. Am I right? Yes or no? Right, right? Okay. So when we substitute in the value, we are going to have y equals to 1 minus x. Then this and this will cancel to give us plus x squared minus x raised to the power of 3 all over 3 plus x raised to the power 4 all over 3. Oh, no. Here is not 18. Cannot give me 18. 4 times 6 is 24. Yeah, this is 24. Sorry. So we write x raised to the power of 4 all over what? 24. Hope I'm right. Hope I'm right. Look at the box. Is there any mistake? Yeah. Hope I'm right. Okay. So let us iterate up to n equals to 3. N equals to 3. Amen. So if we iterate up to n equals to 3, is what we are going to get. It means, so if we now say n equals to 3, there will be n subscript 3 plus 1 equals to y3 plus the integral x naught is 0 to x, then open bracket x minus y3 is this. So this is how we are going to write it: 1 minus x plus x squared minus x raised to the power 3 all over 3, then plus x raised to the power 4 all over 24, close brackets, dx. So let us integrate this. So if we integrate this, we are going to have y4 is equals to y3. But already in the boundary condition, our y subscript 3 is what? 1. There is 1 plus integrate. Okay? Let us not integrate. Let us first open this bracket. X minus 1 plus x minus x squared plus x raised to the power of 3 all over 3 minus x raised to the power 4 all over 24, close bracket, right? Dx. Amen. Looking very beautiful. Okay. So if you agree with me, okay, I think the iteration, this is the highest iteration we have done compared to the first, second, third examples. True or false? Okay, so here will now be, we can add this to this to give us y4 is equals to 1 plus integral 0 to what? X, open bracket, this plus this is 2x minus 1 minus x squared plus x raised to the power of 3 all over 3, then minus what? X raised to the power of 4 all over what? 24 dx. So let us integrate this value. Y4 is equals to 1 plus integrate this, we are going to have 2x raised to the power 2 all over 2 minus integrate this x minus x raised to the power of 3 all over 3, then plus x raised to the power 4 all over 12, right? Then minus what? Minus 24 times 520 carry to 10, 120. Go. Minus x raised to the power 5 all over what? 120. Am I right? Look at the board very well. I'll tell me whether I'm right or wrong. 120. Am I right or wrong? Please look at the board. Tell me. Yeah, this is our fourth iteration. So at this point, we said y of 0.2, right? So it means x is equal to 0.2. So it means our y of x now becomes 1 plus this and this will cancel, x squared minus x. Okay, let's bring this minus first. So here will be 1 minus x plus x squared minus x raised to the power of 3 all over 3, then plus x raised to the power of 4 all over 12. Hope I'm right. Okay. Yeah. So so good. Here is minus x raised to the power of 120 all over. Okay. So if our x is 0.2, 1 minus 0.2 plus 0.2 all in square, then minus 0.2 all in raised to the power 3 all over 3, then plus 0.2 raised to the power 4 all over 12, minus 0.2 raised to the power of 5 all over what? 120. So just use your calculator to do your addition and subtraction. Then at the end of the day, you arrive at the final answer. Okay, gentlemen and ladies, this is where I'm going to draw the curtain. Thank you for your time. I wish you a wonderful day. Please, I want you to like, comment, and share. Thank you, and God bless you. Bye.